here we have an exponential function. And I say it's exponential because rather than having x raised to a power, here we have x as the power. So x is the power itself. So we don't have many tools to solve exponential functions, but if you look carefully, it looks like this is a disguised quadratic. And I say that because 3 to the power x, if we were to square it, we'd get 9 to the power x. Let me show you how. So if you rewrite 9 to the power x as 3 squared to the power x, that can be then written as 3 to the power 2x. And let's just write the rest of the expression as it is, plus 6 times 3 to the power x minus 2 equals 0. Now, when you see something like this, where you have a difference as a power, you can remember that if you have two numbers divided, so if you have a to the power m divided by a to the power n, that should give you a to the power m minus n. So in the same way, 3 to the power x minus 1 is the same as saying 3 to the power x divided by 3 to the power 1. So we can put that back into our expression here, and that gives us minus 1 over 3 times 3 to the power x, because that's really what 3 to the power x divided by 3 to the power 1 is. It's 1 over 3 times 3 to the power x, plus 6 times 3 to the power x minus 2 equals 0. So now, if you look carefully, you will see that we have 3 to the power x, and we have 3 to the power 2x. So if you square this, if you were to square the 3 to the power x, you would get 3 to the power 2x. I can write it like this: 3 to the power x squared equals 3 to the power 2x. So therefore, we have a quadratic equation. All we need to do now is write it as a quadratic equation. So if I replace 3 to the power x with y, then 3 to the power 2x would be y squared. So my expression then becomes y squared minus 1 over 3y plus 6y minus 2 equals 0. So that looks much more like a quadratic equation. So I can now combine these like terms, there in terms of y, and the negative 1 over 3 plus 6, that gives you 17 over 3. So it's y squared minus 17 over 3y minus 2 equals 0. I'm going to attempt to factorize this. So I'm going to multiply both sides by 3. So that'll give me 3y squared minus 17y minus 6 equals 0. And I can probably factorize that. So 3y and y, so that's my 3y squared is 3y times y. And my negative 6 is probably going to be 6 times 1. And I'll probably need a negative there and a positive there. So that looks correct. So I can then say 3y plus 1 equals 0, or y minus 6 equals 0. So y equals negative 1 over 3, or y equals 6. But of course, the question wasn't about y, it was about x. So we now replace y with 3 to the power x. So 3 to the power x equals negative 1 over 3, or 3 to the power x equals 6. So this 3 to the power x equals minus 1 over 3, there's no solution for that. It's not possible to raise 3 to any power to get a negative number, so there's no solution for that branch. But 3 to the power x equals 6 can be solved. So if we take logarithms to the base 3 of both sides, we get x log 3 to the base 3 equals 6. And log 3 to the base 3 is just 1. So we end up with x equals log 6 to the base 3. And that's your final solution. So we used logs in the end, but to answer a question like this, it's important to realize that it's a disguised quadratic.